Hi there, Huskies. So yesterday you're supposed to do lesson 2 of your comparing and ordering integers. So just as a review, I'm going to go over those together with you. So for homework, you're supposed to complete lesson 2, complete the number line by dragging the dots, then order the integers from least to greatest in the box. So to begin with, you're supposed to drag this. So the yellow was supposed to be to the -2. Okay, so let me go ahead and do that. So if I was going to do, I would drag the yellow to -2, -4, and then there would be -1. Okay, so again, we're trying to go from least to greatest. That means the smallest to the greatest. So we know the farther the negative number is, the least that it is. So we have -4, -2, and -1. Okay, that would be the answer for that. Now, if we're doing the ordering for 3, -2, and -1, we would have the 3 as a positive here, the -2 here, and the -1 here. In order from least to greatest, we know that the farthest to the left, the negative, is the least, so it's -2, -1, and 3, +3. Number 3, we do the same. We plot the same, so -2 would be there, -4, and then 1. Then we list it here. It's going to be -4, -2, and 1. Then when we do our, I think that's the same answer for these two. Okay, for 1 and 3 is basically the same, right? So the next thing that we're going to be doing is we are going to drag the correct inequality. So we know, I'm going to go ahead and write it out, -5, -2 is actually going to be the greater number. So again, this is the less than. -5 is less than -2. 1 is greater than -4. -1 is greater than -4. -2 is greater than -3. Okay. So just a reminder that the farther the negative is from the 0, the less that it is. The greater towards the 0, the greater it is. Okay, so make sure that you note that on your journal. Okay, so we're going to go ahead and clear the screen. You can pause here to help you and write that down or to review for your notes, okay? I'm going to stop here. Okay, I'm going to clear the screen. And I'm going to go back. If you feel like it was too rushed, remember, you can pause the video. You're not in real time with me. So that's the bonus of us doing a flipped classroom like this, okay? So I'm going to go down and we're going to do lesson 3 today, classifying rational numbers for Thursday, September 23rd, 2021, okay? So if you go to slide number 13, let me go ahead and put this in present mode. Our objective is I can classify rational numbers using Venn diagrams with, as much as accuracy as you can get. So for an example, we need to know what a rational number is. Okay. Now, a rational number, just want to be clear, as we remember, is a number that can be written kind of in a fraction form. Okay, so think of it as a fraction form, a over b. This fraction form, where a and b are integers, remember integers are negative or positive numbers, and b that is equal to 0. Decimals, fractions, mixed numbers, and integers are all examples of rational numbers, okay? So here's a good plot to help you remember. The a here is the numerator, okay? That's our numerator, number that's on top. And it's also our dividend, the number that goes inside of a box when we divide something, okay? And it can also be the same as a divided by b, or b as the denominator, the divisor goes outside the box. So let me give you an example. Let's say I have 8 over 4, okay? 8 would go inside my box, and 4 would be outside my box. Okay? 8 can also 8 can be written as 8 divided by 4, just like this. Okay? So just remember that the number that goes on top of the fraction could go inside that divisor box to be divided into. And that 4, the bottom denominator, will go on the outside. Okay? Just keep note of that. That's important for your test coming up. Now, as you go here, you can show a number is also rational, okay, by writing it in this form, A over B. Here's an example. If we have 14 and it equals 14 over 1, that just means it's a 14 whole, right? We write a whole number over 1 to turn it to a fraction. Okay? So we have 14, we do 14 over 1. If it was 2, it'd be 2 over 1. That's how we get it into a whole number, into a fraction. And let's say we have a crazy decimal like 0.85, right? What do? Well, if you remember from your place value, this is something that you should know, right? This is in the hundredths place. So I would have 85 over 100. And then I would try to reduce it to its simplest form. Okay? Reduce. So when we reduce, it equals to 17 over 20. Okay? Because we divide by 5, we have the same multiple. We can divide the top and the bottom, and that would give us to our reduced form. Now we need to write the decimal as a fraction. Okay? Remember, the decimal is only 85 hundredths. That's why we have the hundredths here, which means 85 out of 100. Simplify that fraction after. Okay, and this is when things get a little bit difficult, but you got this. So don't feel like it might be too hard for you. I want you to do your best. So if we go ahead and we go to slide number 3, example 3, we have 5 and 1/2. Okay, this is a mixed number. So what do we do in a mixed number? We just change it into an improper fraction. And this is what we do. We have 5 and 1/2. We have 2. Remember, you have to multiply that 5 times 2 plus 1 more. So you would put all of this for the numerator, right? What we have to do. So 2 times 5 plus 1 over 2. We multiplied that all together. 5 times 2 is 10, right? Plus 1 is 11, and that's what you get. And that 2 would just go exactly under 2. So you have 11 over 2, okay? Again, if you need to rewind the video to help you recall what I just said, that's what we're doing, okay? All right, so what are you doing today? We're going to go ahead and reflect that now. Let me go ahead and go back to that. Okay. So you today are doing a Venn diagram in a graphical illustration. That means in a graph used to show relationship between various sets or data groups. So we need to consider the following example. Okay, we have Texas, Harris County, and Houston. So A, if someone is from Houston, are they also from Texas? Why or why not? And then you're going to go ahead and explain to me what you think. Okay? B, if someone is from Harris County, are they also from Houston? Are they in that circle of the Venn diagram? And C, if someone is from Austin, then which of the Venn diagram do they belong to? This is where we need to use our big brain and our diagram clues to figure that out. Okay, so that's something I'm going to be checking for you as you're going on. All right, here's another thing. So we can apply the same logic to classifying rational numbers, integers, and whole numbers. Okay, rational numbers are, of course, numbers that can be written as fractions, the A over B, like I showed you. Integers are the negative and positive numbers. And whole numbers are just regular, positive, good old numbers, like 75, 5, and 102. Okay? So whole numbers are basically all positive numbers. And includes the whole numbers and their opposites. And with rational numbers, well, they can be written as fractions, terminating decimals and repeating decimals. Okay? So also in your lesson 3, I want you to work on this as well. Okay? You need to type an X in every box for each category that applies. The first one is done for you, -12, and it's an integer and a rational number. Now, if you need to go back to the previous slide to help you figure that out, go ahead and do that. This is going to help you on your test. Here's another example. Number 2, come up with your own Venn diagram, similar to the Houston example. If you go back to the previous slide, oops, let's see. Go back to this Houston example, you create your own little Venn diagram. Maybe list Disneyland. I don't know. List cities, right? So you can go ahead and list what you think is better. So remember that whatever's in the circle belongs to that group, okay? Drag each circle to the correct Venn diagram category. So whatever, -1 4/5 is, you'd put it in each category, just like we have over here. So use these diagrams to help you. Okay? And then that's it for lesson 3 today. Remember to work diligently on this notebook, and it will be due on Friday. All right, everybody. Bye. Have a great day.